Okay, so section 6.2, pre-calculus 30, this is going to be 4D. Let's work through this one here. So this one right here, 4D. So what we're trying to do is write each expression as a single trig function. It may be pretty easy to see that there is an identity that matches up with this, but it may not. So on page 305, that's your friend, that page. So this page right here has all of these sum, difference, and double angle identities. There's also the Pythagorean reciprocal and quotient identities from 6.1. You might want to just check those out. You should be starting to memorize some of those, so those ones should be a little bit easier. These ones here, though, you might not have memorized at all yet. That's just fine. So back to the question. It says 2 cos squared of, and remember, this pi over 6 is just a theta. Okay, don't let it scare you. This is like, so 2 cos, if you want to look at this, C-O-S, squared theta minus 1. Does this show up anywhere? Maybe not the other one, but maybe does this show up anywhere? What's this down here? Is that it right there? 2 cos squared theta minus 1. See that? So this actually equals cos of 2 theta, or 2a. So just again, this right here is the same pattern as we see right here. So for D, 2 cos squared pi over 6 minus 1, that actually equals cos of 2 times whatever that theta is. And so this is, and this is in brackets as well, of course. So this is cos of pi over 3. Does that look good? Does that make sense? Any questions about that? So let's take a look at E then. 1 minus 2 cos squared theta, right? Really that's 1 minus 2 cos squared theta. Just forget about this pi over 12 for now. Let's look at this pattern. So 1 minus 2 cos squared theta. Oh, that was close. Sine squared. Is there 1 minus 2 cos squared theta? Oh, look at this. This is close. 2 cos squared theta minus 1. Boy, if we had 1 minus 2 cos squared theta, that would be awesome. Is there any way that this could be made into 1 minus 2 cos squared theta? Yeah? Divide by negative 1 or remove a negative 1 as a factor. Now, this is a statement of truth, right, in math? So can we apply the properties of equality to rearrange this a little bit, right? Because this is already a proven identity. So what I'm saying is, let's take a look at just this little bit right here. I can just clip that out and just throw that down here. So if I want something that's pretty close, I probably could get away with taking a negative 1 out of there, and then I'd have to take a negative 1 out of the other side too. So what about this? Cos of 2a equals, with a negative 1 there, that means the negative 1 becomes positive, and this positive becomes negative. So how does that look? Does that look pretty close to what we have? Yeah, it sure does, right here. So that means we need to focus on what would be this part right here. So with all this mess, let me just get rid of D here. Okay, let me get rid of a bunch of stuff here. So from that, we get this, and pi over 12 is our angle. So cos of 2 times pi over 12, and we're going to have the negative of that. So negative cos pi over 6. Now, I don't know if that's what they have in the back of the book, negative cos pi over 6. If you look at your unit circle, you could write this as a positive value, right? If they want positive, if they don't like the negative, this is negative cos pi over 6. So pi over 6 would be, up here somewhere, right? That's 30 degrees. So the negative value of that, is there another cos function that would be the negative value of that? Well, C-A-S-T. So where's the negative value of this? Well, cosine is positive down here, but it's negative over here. So there would be a couple other angles. You'd have this angle right here that would work, and you could have this angle right here that would work. But I won't get too far into that. If they don't like the negative, you could rewrite it another way. that would give you the same value with a positive trig function, but I don't know. In the back of the book, has anyone checked this? Sorry? They like the negative? They're okay with it? Okay. So that's good. Okay. All right. Okay, so for this one, 5D is the same thing. So express as a single trig function if you can. So what we've already mentioned is that it'd be a good idea to take a look at rewriting some of these things. Sorry. Some or all of these things right here, rewriting them. So use other identities to rewrite them a different way. Now you don't have to do all of them. In this case, I don't think we would do all of them, but you could try and rewrite one or two or all three of them just to see if any patterns emerge. Like to see if you can combine any like terms after they've been rearranged, or if you can divide out any common factors. So with this one here, cos cubed, okay. So what we might want to do is rewrite the top as cos squared x times cos x. Okay? Now the reason why I might do that is because I know that I can rewrite cos squared. Right? I can rewrite that as something different. On the bottom, cos 2x, let's see, if we go back to the, where is it? Give me a second. Is this the page? Oh, well, some double angle formulas, I guess, are right here anyways. So cos of 2x right here could be this one, right? Cos squared a minus sine squared a. So that might be a good idea. So let's go here. Cos squared x minus sine squared x. I don't know. Again, I'm just kind of working through this like you might work through this. And then plus sine squared. Okay, well, maybe I don't change that one. Now, why wouldn't I change that one? Well, because I'm seeing that this is minus sine squared x plus sine squared x. That's going to be pretty handy to eliminate some things in the denominator, because this is now just, they're all added, subtracted. See that? They're not multiplied. These are just added to each other. This is added to this one. You see that? So in this way, you could say this sine squared and this sine squared cancel each other out. It's a negative and a positive. And now what have we got? We've got this with this, because these are all factors. Those are multiplied. This is the only thing left down here. What happened to cos 2x? I changed it to this. Cos squared x minus sine squared x. Let me go back. Using this identity right here. Okay? Now, there's other ways you could do this. It's not like I just, hit the jackpot on the first roll here. There's other ways you can do it, and I'll do it a second way too, but you see you end up with cos x here, and I think that should be the answer. Cos x. So what's another way you could do that? Well, okay, so let's do this. Let's go from this cos squared x, cos x. Okay, let me just rewrite some of the stuff. And cos of 2x plus sine squared x. Okay, so let's write this maybe as 1 minus sine squared x. 1 minus sine squared. Maybe you tried that. Times cos x. Okay, and then cos of 2x is there another identity for cos of 2x? Cos, oh yeah, there's lots. We could change this bottom one here to, let's say, 1 minus 2 sine squared x. You see that? And then, okay, so your question was, sorry, what? Where is the top? Like, where does this come from? Like, where does this come from? Okay, so that's that should be our identity here on 30. Was it 302? Nope, 305. Yeah. So right here, you see, there's lots of cos double angle identities. So there's actually 3 that you could use. I think for the first one, I used the first double angle identity. Now I'm trying this one. Are you seeing that?
But I thought it was cos squared.
Okay, no, on the let's go back here. See, look at on the bottom, it's cos 2 times x. Up, this 2 right here means squared. This 2 means it's 2 times the x. This means that it's sine times sine. This means that it's cos of 2 times x. Is that what your question is?
The top cos
This one here? Okay, so this one here. So you're wondering how I got from here to here. Is that what you're saying? Okay. So do you remember the Pythagorean identity? Cos squared x plus sine squared x equals 1. And if you go back to your notes there, we rearranged this one. And I took sine squared to the other side and made it a minus sine squared over here, which got rid of that. So do you see how cos squared equals 1 minus sine? That's one of the forms of the Pythagorean identity. Now, I know you're just fresh at this. It's like, wow, how am I supposed to know that? It will come with time, okay? But for now, just have all of your identities kind of on a page if you can, or somewhere really handy. But again, yeah, you don't have to know that as quick as others know that. Don't worry about it. But that's where it comes from. So then again, this is just another option. So if we follow this through, watch what happens here. This and this are like terms now. We can combine those. And so that's going to be, I'm going to run out of space here. I'm going to move this down a bit. This is going to be 1 minus sine squared x on top times cos x. And this is going to be on the bottom 1. What's negative 2 plus 1? Negative 2 plus 1 is minus 1. So look at what we have on the bottom. And if you did it this way, you would be able to say, hey, I have a common factor on the top and the bottom, and there's my answer. Okay, does that make sense for anyone that's wondering? Now, there may be other ways as well, but those are just kind of two ways. So if you try that, if you go on a different path than someone else does, you still could get to the right answer. Just keep working on those identities. Just keep replacing certain things with other things that you know to be true, and then watch things just kind of fall into place.